Good day, ladies and gentlemen, personalities. Today we are dealing with quadratic involving sets, aka complicated quadratic. I call it complicated quadratics. Why do I call them complicated quadratics? It's because some of you guys, when you see them, you feel like running away. So for example, let's say they say solve for x in something like this. The question is, how do you go about solving something like that? All right. So how do you do that? Okay, so ladies and gentlemen, personalities in maths, it is a standard practice. This is a general practice that we do as mathematicians, that when we see something that we do not know in maths, we try to make it disappear somehow so that we can be able to work with something that we know. Okay, we have been dealing with solve for x and we have absolutely no problem with them. But now when you start involving something like this, a square root, now you are giving us a problem. Okay, so we'll have to find a way to actually get rid of it so that we can bring these things to normality. So when we bring these things to normality, then we can be able to solve it in a way that we know, and then using the routines that we are used to. Okay, so how do we then remove this? Okay, so what we're going to do here is, okay, we want to remove the square root, right? So how do we remove a square root? So what you will do is, you will say square root of x plus 1, and then you just put squared. Okay, that removes a square root sign, and then is equal. But now, because this is an equation, whatever you do on the left hand side, you must also do on the right hand side. So here as well, you're going to say 5 squared. Okay, now from here, you're then going to get what? You're going to get what? You're going to get x plus 1, right? And then which is equal to what? Which is equal to 25. Okay, this is not a quadratic one, but this is where things start, so that we can actually get the background in terms of what you need to do with things like this. Okay, so you get x plus 1, and then this is something that we know, guys. Can you remember that? So we take this one to this side, and then we end up with x is equal to what? Is equal to 25, and then you take this one to the side, minus 1, and then you get x is equal to what? Is equal to, it is equal to 24. Okay, now remember, when you have found the answer, you must always test the answer if the answer is okay. That is very important. You don't necessarily have to test it on a formal paper. You can test it somewhere else, and then okay, but sometimes they do ask you to do that specifically, and then you need to do it. But you cannot leave this here. I will show you later why not, but you cannot leave this here without having tested it. Okay, so let's test it. So we've got x is equal to 25. So let's test. So remember, when you test, you've got root x plus 1 is equal to what? Is equal to 25. Okay, so remember, when you test, you must take the answer that you got, and then you must substitute it here, and then the left hand side must be equal to the right hand side if our answer is correct. But if the answer is not correct, what will happen is that the left hand side will not be equal to the right hand side. Now let us test. So this x is 24, so you're going to get 24 plus 1, which is equal to, bring down this 25, and then what is 24 plus 1? It's 25, so it's square root of, I'm talking nonsense. I must put 5 here, not 25. I must, because I'm bringing down the original equation. Okay, so, and then you end up with what? You end up with this 5, bringing it down, and then what is square root of 24 plus 1? Is square root of 25, which is equal to 5, and what is square root of 5? Is 25. So we've got 5 is equal to 5, which means the left hand side is equal to what? Is equal to the the right hand side. Okay, so that means that our answer is correct, but you don't necessarily have to do all of these things. I did this step-by-step process so that just to show you how it's done, but basically you can simply just take this number as it is and then quickly plug it here with the eyes of your mind, and then be able to see if the answer that you get on the left hand side is indeed the same as the answer that you find on the left hand side. If that is the true, then you know that you have succeeded in finding what you need. Okay, wonderful. Now let's go to the next one. Let's say, but before we even go there, one person can ask, why is it that when you put squared in a square root of something, then you get that something? Okay, so remember guys, so basically the claim here is that square root of a, and then you put squared, is equal to a. Now the question is, why is that the case? Okay, now guys, remember in terms of the sets rule, when you've got square root, when you've got a, the square root of a, this is same as what? This is same as a to the power 1 over 2. Okay, so this is, so a square root of a squared is same as a to the power 1 over 2 all squared. And then from here, you remember the rule that says that if you got a to the power of something and then something outside, you just multiply those two things outside. So you'll end up with a to the power half times 2, and then half times 2, 1 times 2 is going to be 2, and then 2 divided by 2 is going to be 1. So this is a to the power 1, and then this is a. So this is how you get this thing here. Okay, so square roots, when you have a square root of something and then you want to remove that square root, just add squared, and then you will definitely be able to remove it. But when you are busy with an equation, you can't square one side. When you square one side, then the other side should be squared as well. Okay, great. Okay, let's go on. Let's say this time around we've got something like this. We are still solving for x. Solve. Now we're doing the quadratic now. Okay, so there I just wanted to emphasize the methodology. All right, okay, let's say you've got 1 plus root x plus 1 is equal to x. Okay, so now remember earlier you had what? You had root x plus 1 is equal to, so root x plus 1 was alone. Okay, okay, and then you were able to actually do something in order to remove the square roots. So here it is not alone, there is another number, this 1 plus this. Okay, so in order for you to be able to do these things properly, the first thing that you'll have to do is to get whatever that has a square root, get that thing alone. Okay, that's the first line of defense. So in this particular case, you will take this 1 to the other side, and then you will remain with square root of x plus 1 is equal to x, and then when you take this 1 to this side, you're going to have minus 1. Can you see that? Yes. So now you've got whatever that has a square root sitting here alone. Now you are sorted. Now from here, you will now add square root both sides. Not square root, add squares. So you're going to say square here and then square here. Now when you square here, you're going to get what? You're going to get x plus 1 in terms of the rule that we spoke about earlier. And then here, this is going to be the same as x minus 1 times x minus 1, which is, okay, I'm gonna use a shorter method. You can use a longer one, it's no problem. So basically, if you multiply all of these things, you will get x squared minus 2x plus 1. Can you see that? Okay, and then now you've got all of these things mixed. Now in order to solve quadratic very well, you must have 0 on one of the sides. So you're going to take these two into the side, and then you're going to remain with 0. So you're going to have 0, which is equal to nothing other than x squared minus 2x plus 1, and then take this x to this side, and then minus x, take this one to the side, minus 1. Okay, so this is same as 0 is equal to, and then bring this x squared as it is a squared, and then minus 2x minus x is going to be minus 3x, and then plus 1 minus 1 is going to be 0. So this is same as what? This is same as x squared minus 3x is equal to what? Is equal to 0. Do we agree? Yes, we do agree. So when you are here, this becomes a normal quadratic. You find a common factor, which is x in this particular case, and then you get x minus 3 equal to 0, right? And then x is equal to 0, or x minus 3 equal to 0, and then x is equal to 3. Okay, so you've got two solutions. You've got x is equal to 0, and then you've got x is equal to 3. Okay, now guys, we did say earlier that you must test your solutions. The case is still the same. You must still test your solution. You can't have untested solutions. You can't parade around with untested solutions. Your solutions must be tested so that you can actually be sure of their authenticity. Okay, let's check. So we're gonna check this one. Okay, so when we check, guys, as we said earlier, when we check, okay, let's check here. Let's check. So when we check, what we do is we rewrite the equation literally as it is. In this case, we've got 1 plus square root of x plus 1, and then equal to x. Okay, so we're gonna test both values. We're gonna substitute them in this equation, and then the left hand side must be equal to right hand side for answer to be correct. If the left hand side is not equal to right hand side, then we know that our answer is what? Our answer is wrong. Right, great. Now let's shoot. Okay, let's start with x equal to 0. So 1 plus 0 plus 1 equal to 0. Okay, so it's 1 plus, and then 0 plus 1 is 1, and then square root of 1 is 1, equal to 0. So 1 plus 1, so 1 plus 1 is 2, 2 is equal to 0. Guys, we know that 2 is not equal to 0. Okay, we know that 2 is not equal to 0. So that means that our answer is what? Our answer is wrong. Okay, so we then say, okay, x is then not equal to 0, because this answer, when we tested it, it doesn't work. Okay, now let's test the second one. What is the second one? The second one is x is equal to 3. Let's test x is equal to 3. Okay, let's do the same thing. So we've got 1 plus square root of x plus 1, which is equal to x. Okay, we're substituting x is equal to 3, so we're going to say 1 plus square root of 3 plus 1 is equal to, and then we've got 3 here. Okay, what is 3 plus 1? 3 plus 1 is 4. Square root of 4 is what? Is 2. So 1 plus 2 is, so we've got 3 is equal to 3. You can put it in a calculator if you are lazy to count like myself. So the left hand side here is equal to the right hand side. So in fact, x is equal to 3. So this is the only solution that works. Guys, I think I've changed my mind. I said to you earlier that when you test these solutions, don't test it in an official paper. Actually, do that test it on an official paper, because sometimes you get something like this. So now if you can't just have two solutions like this and then just pop out of nowhere and say x is equal to 3. How do we know that? Okay, so please do check on an official paper, and then so that if it happens that one of the solutions doesn't work, you will have a substantiation of why you are saying so. All right. Yes. So ladies and gentlemen, personalities, this is how you deal with this kind of complicated kind of quadratic equations. So we've got steps that we've outlined for ourselves. I know you guys like steps. When people see steps, oh, they get very happy. I do not know why. So basically, okay, let's develop these steps together so that you can have something to go home with. So what did we say? Okay, so what are we actually doing? Solving quadratics involving Surds. Okay, so we're going to write steps together. So step number 1, ensure that the term that involves square root is alone. Okay, very important. Make sure that the term that involves is alone. So if it's not alone, do some means to make sure that it is alone. Okay, and in step 2, what do you do? Square the term involving square roots. So that you can remove it. Okay, remove it. But when you do that, you must be careful. So NB what you do on the left hand side, you must also do on the right hand side. Okay, so what you do on the left hand side, you must also do on the right hand side, which is RHS. Okay, this is important. And then from there, step number 3, what do you do? You then solve. But number 4, test your solutions. Okay, why must you test your solution? Because sometimes only one solution works. Okay, sometimes it's only one solution that works. So make sure that you test your solutions. Okay, so these are the steps that you follow, ladies and gentlemen, personalities, in order to solve this equation involving sets. So ladies and gentlemen, personalities, I now do hope that you will never have this problem. Okay, when you see any quadratic that has a square root, you will definitely chow it. Okay, thank you very much for tuning in. This is Mqondisi Macaba from Thembela Maths Club, a club that helps learners to understand mathematics. If you have any questions or comments or something that is not clear, or if you see that you've made a mistake somewhere, make sure that you comment on the comment section below so that you can tell us, so that we can fix that mistake. Thank you very much, and goodbye.